Okay, so in this video we're going to be going over problems in section 4.6. Specifically, we'll do number 9. So these problems are solved using variation of parameters. And we're going to start here with y double prime plus 16y is equal to secant 4t. Well, the first step to any of these problems is to solve the homogeneous equation. So we're going to get r squared plus 16 is equal to 0. You use the quadratic formula and you'll end up getting a complex number 0 plus or minus 4i. Not too bad. Okay, and the homogeneous solution to this would be c1 cosine 4t plus c2 sine of 4t. Okay, but since it's not equal to 0, we have to add a particular solution. And this is what's tricky, because we can't use the method of undetermined coefficients for secant. It's not allowed. Can't be done. So, the formula for the particular solution is equal to v1, the solution of the homogeneous equation. In this case, it's 4t, cosine 4t, plus v2, the solution next to c2, sine 4t. Okay, that's great, but how do we solve for v1 and v2? Well, there's another formula. The first formula is v prime. This is just a variable. So you never really take a derivative of it, but you just keep it as v prime of 1 times the number in front of v1, which is just cosine 4t, plus v prime 2, the number in front of v2 is just sine 4t. And these are always equal to 0. The second equation is the derivative of the well, let me just write it out. If this is f of t, and this is g of t, well, the formula is v prime of 1, f prime t, plus v prime 2, g prime t. Okay. So now what? Well, we take the derivative of cosine 4t, and we get v prime 1. Well, this will be a negative 4 out in front, right? Because the chain rule, negative 4 v prime 1 sine 4t plus 4 v prime 2 cosine 4t. And this is equal to, well, the formula, I didn't write it here, but it's equal to f over a, where f is the equation the differential equation is equal to, and a is the coefficient in front of y double prime. So f over a here is just secant 4t over 1, or just secant 4t. And to solve for this, you have to solve for v prime of 1 and v prime of 2. And you can do this doing two ways. You can use a matrix, right, or a system of equations. And I prefer to use a system of equations because it's just easier for me. So we have, again, I'll rewrite it here. We have v prime 1 cosine 4t plus v prime 2 sine 4t is equal to 0. And we have v prime 1 negative 4 v prime 1 sine 4t plus 4 v prime 2 cosine 4t is equal to secant 4t. And we're going to solve this system of equations. Well, if we solve for v prime of 1, we get a negative tangent t. So v prime 1 is equal to negative tangent 4t. But don't forget about this v prime 2. So v prime 2. And if we plug in v prime 2 or v prime 1 into this, we get a double negative, so we get 4, positive 4. Tangent is sine over cosine, so sine squared 4t over cosine 4t v prime 2 plus 4 v prime 2 cosine 4t is equal to secant 4t, kind of running out of room, but that's a secant 4t right there. And if we multiply by a secant 4t, divide, secant is just 1 over cosine, so we could multiply by a cosine 4t, and that will equal 1, and this will all simplify. So let's do that. Let's multiply by a cosine 4t on both sides. This cosine 4t will cancel. So we're left with sine squared 4t v prime 2 plus 4 v prime 2 cosine 4t. Cosine times secant is 1. And what we'll notice here is we have a 4 v prime 2 times sine squared 2 4t plus 4 v prime 2 cosine 4t. I'm going to write that here. Or let's write it here. These are going to go to 1. So you have 4 v prime 2 is equal to 1. Or v prime 2 is equal to 1. And if you plug that, or 1/4, sorry. If you plug that in here, you have v prime 1 is equal to negative 1/4 tangent 4t. Okay, so now what? Well, we got to plug them into this formula for the particular solution, but we only have v prime 2 and v prime 1. So we're actually going to have to take some integrals to solve for v1 and v2. So let's do that up here. So v prime 2 is equal to 1/4, and v prime 1 is equal to negative 1/4 tangent 4t. Well, the integral of v prime 2 is just v2 is equal to the integral of this, which is just 1/4 t. That wasn't bad. V prime 1 is a little bit more difficult, but v1, the integral of v prime 1 is v1. And using a integral table, you'll find this to be equal to negative 1/16 ln secant 4t. This is just one of the integrals in the back of the book. So now we have v1 and v2, and that's great, because now we have our particular solution. So to solve here, we have to plug in v1. So we get the particular solution is equal to negative 1/16 ln secant 4t times cosine 4t plus, I'm going to write it down here so I don't run out of room, 1/4 t sine 4t. So this is our particular solution, but we want the general solution. So the general solution is just this, our homogeneous solution, plus our particular solution. So the final answer for this problem would be c1 cosine 4t plus c2 sine 4t minus 1/16 ln secant 4t cosine 4t plus 1/4 t sine 4t. So that would be how you could find the general solution for this differential equation using variation of parameters. Hope this helped.